Okay guys, this video is going to be the second one of the probability trees. So the first one, you'll see why it's a little bit different as I go through the questions, okay? So I've attached the PowerPoint of these questions on them as well, just in case you can't see them properly in the video now. Okay, so let's have a look. There are green and blue counters in a container. Kevin takes at random a counter from the container. He replaces the counter in the container. Kevin takes a random at second counter from the container. Complete the probability tree. So this first part is identical to what you're used to from the previous session. Okay, 7 out of 8 for the first counter to be green, and so therefore he can either pick green or blue, and you know that they have to add up to one whole because that's what probabilities do. So if it's 7 out of 8 green, it must be 1 out of 8 blue. And then equally, because it's the exact same situation where you've got green and blue here, 7 out of 8 for green, so it must be 1 out of 8 for blue because they need to add up to 1. Or if he had picked blue the first time, he still could either pick green or blue the second time. So therefore, the green is going to always be the same probability. It's always about green here. So it'd be 7 out of 8, and therefore the blue would be 1 out of 8. Okay, just to remind you, that's his first pick. He could either pick green or he could pick blue. But if he had picked green, then his second pick could either be green or blue. Or his first pick was blue, his second pick could either be green or blue. Okay, so that is 2 marks to begin with, that's fine. Then it says, work out the probability that Kevin picks counters that are different colours. So, I want to show you how to do this. But to do this, I want you to work out each of these separate answers. And I'll talk about why in a second. So let's imagine, so I'm going to ignore part B for just 2 seconds and just say, right, let's do some maths here. Let's say that he picked a green and then a green. Now I told you last time, when you go through the probability tree, you must multiply. So if you pick the green the first time and then a green the second time, that will be a green and a green. It will be 7 out of 8 times by 7 out of 8, because that's what the probabilities here are, which is 49 out of 64. If he'd picked a green the first time and a blue the second, so it'll be a G and a B, it would be 7 out of 8 times by 1 out of 8, which is 7 out of 64. If he had picked a blue the first time and then a green the second time, so blue the first and then green, it'd be 1 out of 8 times by 7 out of 8, which is 7 out of 64. And lastly, if you pick the blue the first time and then a blue the second time, so B and B, it would be 1 out of 8 times by 1 out of 8, which is 1 out of 64. Now, this is going to help us a lot, because this question here says, work out the probability that Kevin picks counters that are different colours. So when he picks a green and a green, they're not different colours, they are the same colour. So we're not going to include that. When he picks a green and then a blue, they are different colours. So that answer here we're going to use. But that's not it. This one here, he picked a blue first and then a green. Again, they are different colours from each other. So therefore this answer is also correct. And lastly, blue and blue, well, they are the same colour. So no, they're not different colours. So that answer doesn't count. So what we're going to do now, we have 2 correct answers. So what we do is we add these 2 together. Now, I don't want you to confuse yourselves. When you work through the probability tree, you must multiply. But once we've established that these 2 answers are both correct, then you add them. So the answer is going to be 14 out of 64 because the denominator is going to stay the same. And therefore that is the answer for that. Okay, going to go for another example now, guys. This time we have to draw out the tree ourselves to begin with. So the probability that a train arrives late is 0.2. James is travelling on train on Saturday and Sunday. Okay, so I'm going to label that as Saturday. And I'm going to go boom, boom. And I'm going to say here, late, not late. And then Sunday. If he's late on Saturday, he could be late or not late on Sunday. Or if he's not late on Saturday, he could still be late or not late on Sunday. Now you know that probability train arrives late is 0.2. And therefore not late must be 0.8. And again, it's the same on Sunday. So it's late is 0.2. So not late must be 0.8. And irrespective of him being not late here, if he's late on Sunday, it's still 0.2. And that is 0.8. So therefore, we've done the first answer. Show that information on the probability tree. We've done that. Okay. Calculate the probability that the train is on time on both days. Now, that there, on time on both days, that there is what you're used to doing from the previous lesson. Okay? On time on both days would be him being not late and then him being not late again. Because that must mean that they're on time. So that would just be 0.8. So not late and not late be 0.8 times by 0.8, which is 0.64. That would just be the final answer. So unlike that previous example where we had to work out all of them and then be like, which one do we pick? Here, because it's just one option of him being on time on both days, we only need to pick one option. Okay? Right, last one's a little bit trickier. So Jennifer is playing darts. She throws 2 darts aiming for bullseye. The probability Jennifer hits the bullseye on her first throw is a quarter. Probability of hitting on a second throw is actually a third. Complete the tree diagram. Now again, you know, first throw, one out of 4 to hit, so it must be 3 out of 4 not to hit. Hit a second throw, she's actually 1 out of 3 to hit, so this one must be 2 out of 3. And because this is all about her second throw, this is 1 out of 3, so this also must be 2 out of 3. Okay, now, this is very important, this next part here. Work out the probability that Jennifer hits the bullseye at least once. So she wants to hit at least once. Now, when a question like this happens, similar to my first example, I'm going to work out all of the different answers first, and I'm going to write a clear idea of what I'm doing here so that when I deal with this part of the question, I've got the information I need. So the probability of her hitting bullseye and then hitting bullseye again would be H and H. So hit and hit, which is a quarter times a third, which is 1 out of 12. Probability of her hitting the first time and then missing the second time would be 1/4 times 2/3, which is 2 out of 12. The probability of her missing the first time and then hitting the second time would be 3/4 times 1/3, which is 3 out of 12. The probability of her missing the first time and then missing the second time would be 3/4 times by 2/3, which is 6 out of 12. Now, the question says the probability that she hits the bullseye at least once. The word at least means that she could hit it once or she could hit it more than once. So hit and hit in this case would be one of the correct answers because at least once means it could be more than once. And this time she's hit it twice. At least once could also mean it is just once. So here, when she hits and then misses, that also counts because that counts as at least one time. She's hit it at least one time. So therefore that answer also is correct. She might miss the first one, but because she hits the second one in this instance, that also counts because she's hit it at least once. When she misses and then misses again, she hasn't hit it at all. So she hasn't hit it at least once. So therefore that answer is not correct. So because these 3 answers are right, I'm going to add those 3 answers together. So 1 plus 2 plus 3 is 6. So it's going to be 6 out of 12. And that there is going to be my final answer. So the first example we went through, it said, if you remember correctly, it said exactly once. The second one just said not late and not late. And this one here says at least once. So if you need to look back at your work in order to do it, please do. But I would say if it makes your life easier, for every question, do what I've done here. Get the answers and then work out what the question really once at the end. Okay? Best of luck.